All right, looking at my humanities data, I am going to do a hypothesis test for the population mean where the sigma is unknown. So using this sample, I'm going to do my hypothesis test. To find my sample size, again, if I did not know immediately what it was, I can do equals count A parenthesis, and then I'm looking at my cost, select that, and of course I have 20. All right, when I am doing a hypothesis test about the population mean, I need to know, and sigma is unknown, I need to know the sample mean and the standard sample deviation. So equals sample mean is just the average of my sample, my data in that sample. And then sample standard deviation, I do equals STDEV, and parenthesis, select my data. Okay, so sample size, sample mean, sample standard deviation. My hypothesized value would be unique in each problem. And in this problem, let's say that I'm supposing the cost is $160,000. So I'm going to enter 160,000. Perhaps I am going to have a upper or lower tail test or a two-tail test, but my hypothesized value is 160,000. All right, in order to find my p-values for a hypothesis test, I need to find my standard error. So to do that, I will equal standard error. To find that, I take my standard deviation, so select what I had before, and then I divide that by the square root of my sample size. So divide by SQRT of sample size. So there's my standard error. Now to calculate the t-test statistic, I will need to take my sample mean and subtract that standard error, and then divide that, or excuse me, my sample mean and subtract my hypothesized value, what it is that I'm trying to figure, or what I'm comparing it to, and then divide that by the standard error. So equals sample mean, select that, minus hypothesized value, select that, and then divide that, all that entire quantity, by my standard error. So I select that. All right, so here's my test statistic. Now, degrees of freedom will be n-1, but you know, if you're not sure, you can do equals, select your sample size, -1. So of course, 1 less than 20 is 19. All right, so depending on what type of test I have, I would have a different p-value. So my p-value for a lower tail, upper tail, or two-tail test is going to be different each time. So let's suppose that I was performing a lower tail test. In order to figure out what my p-value is, I do equal, I have to use a t-distribution because sigma is unknown, so t.dist. Open up that parenthesis. And then the things that I'm going to enter for my t-distribution, that x there that it's popping up, that's the test statistic. So that's what we calculated up here. Comma, degrees of freedom, that was the 19. And then we want to enter true in this third input because it is a cumulative test. And so there's our p-value for a lower tail. Let's suppose that in my test where I'm hypothesizing 160,000, that I wanted a confidence level, or I was going to use alpha is 0.05. Since this p-value is not less than that, then that would mean I don't reject the null hypothesis. So that's for a lower tail test. Now for an upper tail test, I just need to do 1 minus my lower tail value, which again, clearly not something that is less than 0.05, so we would fail to reject the null hypothesis there. And then finally, for a two-tail test, what I will enter is 2 times, and then the minimum of whichever these smaller ones was. So to, figure that out, if we didn't know, do min of, and then first number, comma, second number, two numbers that I'm comparing. I get 0.1144 and so on, which again is not less than 0.05. So in this two-tail test, I would fail to reject the null hypothesis in this case that the mean would be anything different than $160,000.